Welcome back to Impact Quantum, the podcast where we decode the quantum future one entangled conversation at a time. I'm your virtual MC Bailey. In this episode, Frank is joined as always by the queen of quantum curiosity herself, Candice Gilhooly. Today, we're thrilled to be joined by Nir Alfasi, General Manager of the Israeli Quantum Computing Center. Nir's coming to us quite literally from the cutting edge of quantum innovation with a real, functioning quantum fridge behind him to prove it. We'll dive into Israel's burgeoning quantum scene, the role of quantum data centers, and why the future of computing is less Silicon Valley and more global village. Grab your coffee or your cryogenic coolant and let's get started.
Hello and welcome back to Impact Quantum, the podcast where we explore the emergent fields of quantum computing and focus on what that ecosystem is going to look like and how to best position yourself today for the quantum future and how to be quantum curious. Along with me on this journey is the most quantum curious person I know, Candice Gilhooly. How's it going, Candice?
It's going great. Thank you very much. I just want to mention that on the 8th of April, I woke up to snow.
Wow.
I just have to put it out there. I do.
We had a frost warning, so
Okay.
I guess I can't complain too much. But where our guest is, it's 30 degrees Celsius, which is about 86 degrees Fahrenheit-ish. So warm and toasty, I would suppose. And he is the general manager of the Israeli Quantum Computing Center, Nir Alfasi. How's it going, Nir?
It's going great. Thanks for having me, Frank and Candice.
So
really
for
great to
those
be
watching,
here.
thank you. So for those of you watching the video, that actually is a quantum computer over his right shoulder.
Yeah,
Yeah.
exactly.
So
Get jealous.
that is very
Get
cool.
jealous. That's so cool. He had a great background on today already, and then we asked him to drop the kimono and show us where he really was and what we could see,
And that's
we
even
were-
cooler, honestly.
So cool.
Yeah.
I'm geeking out a little bit. Yeah, super
And
cool.
it literally is cool, right? Because, close to episode 0. Ba-dum-bum.
Yep.
Oh.
So one of the things that we've been talking about recently is data centers and how, well, two things, right? One, the 2025, it's April, and it's already been a pretty wild year in quantum computing with all the announcements coming out. First, it started off with kind of the CES kind of, oh no, this is going to be not a thing anytime soon, right? From everybody's favorite GPU CEO to now every company is coming out with these announcements just fast and furious. What's your take on the current state of the quantum computing world?
I think it's advancing really, really fast. So I think there's a lot of hype around it. I think it's only natural. I think the field is going generally in a steady state forward. I don't think we're yet in some exponential rise, or especially in the, physically and technically speaking. But I think the hype is justified. You want this is going to basically change the world. It might take a few years, depends on who you ask. But I think it definitely is something. A new computing paradigm that we're not used to. We don't know it, and I think for me the most important thing and the most I would say encouraging is to see so many startups coming out all around the world, both in Israel but also like worldwide, and I eventually one of them will shine. It might be one of the big players also. But I think it's also like not only that it's going forward, but it's only also expanding, in width. So I think this is very, very encouraging to the entire field.
Absolutely. I think one of the detriments of existing technology industry is that it's focused really in pretty much Silicon Valley and Seattle, right? So kind of one time zone. And I think that there's a certain geographic bias that you have if you're based in an area. And I think that it's encouraging to see this quantum hotspots around the world, like you said, right? There's obviously what you're doing in Israel. There's Montreal apparently is a big quantum presence. Um, Maryland, where I live, actually has a pretty big research center. Obviously, its proximity to DC probably helps. Maybe I was joking. We were joking with somebody the other day who was talking about College Park, Maryland is where the University of Maryland is, but it's also this massive IKEA is there. So we always joke like maybe there's a correlation between presence of IKEAs and quantum hotspots. I don't know. But
then it would be everywhere in the world, right?
That's right. Maybe that's what it is. Like people just really like the Swedish meatballs. I don't know. Or maybe to assemble the furniture without any problem, you have to be a PhD level physicist. I don't know. But I think that's interesting because I've noticed that too, right? Like there are definitely kind of hotspots, but the hotspots are not the hotspots in say technology were, Seattle, Redmond, San Jose, Cupertino, right? All in one time zone. And arguably you could say New York has a pretty solid startup scene too, right? But I've noticed that quantum hotspots tend to be far more evenly distributed.
We also find that the hotspots are now usually in correlation to a major university that's around them. So, for example, the hotspot in Boston is very much connected with MIT and Harvard, right? You have the universities, College Park, Maryland. They have Boulder, Colorado. Today, a lot of news is coming out of Chicago. They've just received there's a place in Chicago, the Illinois Quantum and Microelectronics Park. They've just received an additional $2 million to work with Psi Quantum on more, really establishing Chicago, Illinois as one of these quantum centers. I just wanted to throw that in.
Interesting.
Yes.
So
IQMP, I'm aware of that.
Yeah. Oh, very cool. What are the main problems that you're working on in your lab? You kind of just, what are the main problems you're trying to solve? Like, are they industry problems? Are they kind of, how do we build one of these machines? How do we make them practical?
Yeah, so maybe before we dive into the problems, maybe it's better to, just give you what do we actually do here, and then it might, give a better context to the discussion. So the IQCC, first of all, it's being built and operated by Quantum Machines, which is an Israeli startup. It's the largest Israeli startup. It's a quantum control company, the largest quantum control company in the world, the leading one, with over 300 customers everywhere in all the places you mentioned. We're everywhere. So this is already an established, a well-funded, also a company. Recently, we announced a round of another additional $170 million. So this is already an established company with an established sector of customers. And we got basically the mandate from the Israeli Innovation Authority to build this Israeli Quantum Computing Center, which is partially funded by the Israeli Innovation Authority, but still managed and owned by Quantum Machines. And the idea of the IQCC is to be an infrastructure for to allow basically research and development for third parties. Okay, so I personally do not develop quantum computer here. Okay, I am dedicated to adjust the infrastructure. So I need to do some R&D on my behalf on how to allow the best facility for the quantum ecosystem, I would say, to basically connect and run their R&D on this premise. Okay, so in general, we have these three, and it's really generally speaking, we have these three services. One of them is a quantum computer over the cloud. So you can connect remotely to a quantum computer at the IQCC. We have several technologies, basically. One of them is superconducting quantum computer. We have two processors, one with 17 qubits and the other with 21 qubits. So you can log in, run your algorithms, run your research, and you can do it at the pulse level. So you can go as low as you want in the stack, I would say. So this is one thing that we're enabling, basically. In addition, everything is tightly integrated with supercomputers, with a high performance computing, HPC. So this is why we call it a quantum data center, because it's not only about quantum computers, it's also about classical computers and tight integration between the quantum and classical. And part of it is the DGX Quantum, the project that Quantum Machines has together with NVIDIA on basically, tightly integrating at the hardware level, the control, the OPX 1000 by Quantum Machines, and the Grace Hopper, the NVIDIA superchip. So this is one offering that we have. The second one is basically a cryogenic testbed. So this is for hardware, more for hardware companies. So let's say that you are a startup. You would like to, you think you have the best idea for the best qubit ever. If you want to build the same thing that I have, right behind me, it will take you, first of all, multi-million dollars, but also probably around a year if you're fast. So, we are able to assist startups at their initial phase to test their devices here at the IQCC. And it's very, very important for us to accelerate the ecosystem, basically. So you can start here, and then, eventually we will build your own lab. You will go to your own way, but this is a great start. You get, the state-of-the-art system, which will take you a lot of money, a lot of time to build, and you get it on day one, and you can start running with it. And the third thing that we do is also we give education and quantum workforce training at the IQCC, which we believe is really kind of a bottleneck today in the quantum industry. Like, I've been in the academia for 15 years? So you don't want any person that works at the quantum industry to be after, bachelor, master, PhD, and a postdoc, right? And then, okay, now you can go work at the quantum industry, or maybe you're only a PhD and then you need like 10 years.
Right.
But then maybe it's not mandatory. Maybe you can take good physicists, good electrical engineers. They're amazing. They've been working for 15 years in the industry. Okay, you train them for a few months. You made them a quantum experts, So this is kind of also where the market is heading, because, it's growing rapidly. And other than, money, time, you also need good people. And this is something also that we are aiming to lead at the IQCC as well. So, I mean,
that's
I
really
hope
cool.
That answers your question.
No, it answers it and then some, right? Is it fair to say you're like a quantum accelerator, right? Or
yes,
quantum?
Exactly.
Because
exactly.
I think a couple of things you said there, I think we're just 100% spot on. I don't want to hog the mic because I know Candace I see her eyes lighten up. But I think the number one thing was, there's a lot of people, you're right, that, maybe they have a design. I like the idea that you have, where you have like a cryogenic center where you can be like, hey, I have this great idea. I want to build this hardware. And then let's just give a crazy example. Like, maybe once it gets to a certain temperature, the board cracks or the breadboard cracks or whatever, right? Like it's a great way to test and prototype, right? I think that's brilliant. The other thing too was you're absolutely right. Like there's a shortage of people and skill set in the quantum. I don't want to say the quantum realm because I think of Ant-Man or whatever, but the quantum space is that you're right. Like the amount of people that are going to be needed for this space, if you go through the traditional kind of, PhD in physics, postdoc work, and then industry, that's really going to slow things down. But what if you could take not just electrical engineers, but software engineers, right? And kind of say like, this is how you would code it in traditional, and you could kind of take them and repurpose them into, the different types of algorithms and stuff like that. I remember reading about the different gates that are available inside of a quantum computer and was completely floored and like, wow, this opens up a lot of doors, right? And then it's, and I even wonder, like, are you going to need to offer like remedial computer science for a lot of these people? Because last time I really thought a lot about logic gates at that level was a long time ago. I'm not even sure they teach that to kids today at school. You know what I mean? So, and certainly, not all computer science programs are created equally, right? I'm pretty sure that you would have a different experience if you went to like one of those boot camps where they taught you how to code. Like, not knocking on them, but I don't know how much time they spend on the actual, silicon in that example, right? So I think it's great because you're really kind of building ahead. It's like, if, let's just say, if a company figures it out tomorrow, right? Everything goes perfect for them. They're going to need to hire all these people, the quantum curious, right? And you're going to need quantum marketers. Like, well, what's that mean? How do you market a quantum computer? What's your DTG go to market plan? Like, what's your marketplace look like? And also too the practical stuff. Like, if I'm a data center designer, right? I obviously I have electricians, electrical engineers on my staff, but what are the unique power requirements for quantum computers as they are today, right? They obviously have, cooling systems, but probably not liquid nitrogen based stuff. Like, what does that look like, right? What is that practical kind of like, not even day two stuff. I think, kind of just how do you rack them and stack them, as they would say, right? Like, what's that look like? Um, do you have any questions, Candace?
Well, I was just really interested in the bottleneck idea that there is so much opportunity for other people in this industry, to kind of find a spot where they could be, teaching the knowledge that they have in order to bring people closer to what they need in order to use these systems appropriately. I like the idea that there's a lot of space there. I like the idea that it doesn't have to be necessarily a direct path. That there's, you can take people with different skills and then you can position them in certain areas where then they're able to teach others what they need in order to make these systems effective. I like that kind of collaborative feel, you know. I'm also in my head, I'm kind of thinking like, what kind of problems are you trying to get solutions for by using your quantum computer? Like, what are you specifically looking at right now?
Yeah, so I think the idea of the IQCC, and that's what I like the most. So first of all, I mean, the quantum ecosystem is pretty large and starting to, or at least starting to be pretty large but there are a lot of like small companies, and usually each company works alone. And I think that, at least as I see the future of quantum computing, of quantum computers, like you should really have a dedicated, focused a company working on a certain thing. So I don't see, so for example, let's say that I'm building a quantum computer, right? And I need cables. I will not go and build the cables, right? Or I will not, or let's say I even need a laptop, right? I will not go and build a laptop. I'm going to buy it from the store, or the same with the cable. So I think in my vision, I see that, when you build a quantum computers, you need so many components, and I think like you just need expertise in each one of them. So for example, quantum machines are experts in quantum control. And you can see behind me, for example, you have Blue Force, that they're experts in dilution features. There are other companies, it's fine. But I wouldn't want to see companies build their own, components when you have small companies which are experts in these components. And the same goes, in my opinion, for software and algorithms, right? So at the IQCC, the idea is that we give, we have place for everyone. We can give you the access to each level of the stack. So we have, software companies working here, but also like all over the stack. If you go to, like a computer, right? You have Intel that are making the chips, and you have Windows, and you have Excel, and you have, I don't know, Adobe PDF viewer, right? So it's like you have things across the stack, and that goes the same for quantum computers. So we have
Well, there's a
room
whole
for the person.
ecosystem. There's a whole ecosystem that is going to be needed.
And it's a full stack, right? So you can test the chip. If you have, let's say that you build a filter or an amplifier or something, you can test it with a chip that we provide. You can log in if you have a low-level software that needs to, maybe you run quantum error correction, but on the actual like hardware level, right? You want to learn the noise on the hardware level. You can get access to that. That's pulse level access. If you want to go higher in the stack, you go gate level access. You can run in gate level access here, and then if you're trying to do quantum error correction or quantum algorithms, and I feel like we need to advance in all of this stack. So it's like this is how I feel. Obviously, like the processor itself is a huge engineering challenge, because we still don't have fault tolerant qubits. But the idea is that, okay, maybe we don't need fault tolerant qubits. Maybe we just need good control system and good quantum error correction algorithms, and that will fix it. So I think that's kind of where the industry is going. Like, okay, let's try to improve the qubits. Let's try to improve the software. Let's try to improve the control. Let's try to improve the filters that we have, so we have less noise. So everything needs to basically be better. And so I think this is what we're trying to provide, like accelerate basically the realization of useful quantum computers. That's the idea.
Interesting. And you might be the first person, Candace, correct me if I'm wrong, that has really kind of explained that, the whole ecosystem and has a holistic approach to what that whole ecosystem needs to look like.
Oh, absolutely. Like the way he's talking about how there's so many different positions that are available. There's so much need for people with specific type of knowledge that they could all go into this and be incredibly collaborative, which is always my game. I'm all into the collaboration of it all. I don't care about one company kind of standing up and being the leader. I'd rather there be a whole bunch kind of bringing everyone towards, understanding quantum computing better. But no, I really like how he breaks up the ecosystem in a very different way than what we've heard before. 100%.
And I think it also, maybe it's confirmation bias, but Candace and I kind of had this idea that like when this thing blows up or grows up, right, you're going to need a village, right? You're going to need an ecosystem, right? Like the PC industry as we know it, if you kind of look at the early documentaries and, where it started off with the Altair and these homebrew computer groups, every one of those people that were at those meetings, well, not every one of them, but like each one of them had a startup, had to realize that they had to fix one particular aspect of something, right? So like you said, like, you're not going to go you're not going to go make your own cables, right? You're going to buy it from someone who makes cables, right? And like, I think people take for granted the entire ecosystem that exists in conventional or classical computers. Whereas this is going to be, some of it I think we'll be able to reuse, but some of it's going to have to be completely built from the ground up.
I think like even if you go to, maybe, I don't know, the chip industry, right?
Mm-hmm.
You go to these huge players, I don't know, Intel, TSMC, whatever. You got these huge players. But if you go to their, okay, so maybe even let's assume that there is one that controls 100% of the chip industry. But then if you go to their fabrication facility, I assume that they do not produce the machines that produce the chips, right?
Right, absolutely. Yeah.
Right.
So they buy it from, I don't know, whatever company. I don't want to name names, but they're buying from somewhere, and they have other devices that, so they gathered things from other places, they integrated them together, and then they bring you the best product ever, right? So I think there's room here as well.
But correct me if I'm wrong, but I don't think NVIDIA even owns their own production facilities, right? They lease it from TSMC.
I think so, yeah.
Yeah, I'm sorry I cut you off, but like,
Yeah. So I'm not an expert, but I mean, it only makes sense. Like even when you build a car,
right.
you don't make usually, I assume you don't make your own tires, right? So they're like dedicated tire companies, and it only makes
Dedicated
sense.
glass companies, dedicated,
Exactly.
and the robots. Who makes the robots that put the cars together on the assembly line? It's not
Exactly.
probably not the automatic car manufacturer.
Exactly. So I think there's room for a lot of companies here that are really experts and dedicated. I think there's room for many technologies. I mean, at least the near future. Obviously, there might be one that will rise and just wipe everyone else because it's so much better. But currently, maybe one is better for this task and another one is better for this task. And for this one, you just need high numbers of qubits and short lifetimes, but for this one, you just need small number of qubits and long lifetimes and better fidelities. And you need all-to-all connectivity. You don't need. So I think there's room for a lot of players here, at least in the near future. And I definitely see much more collaborations. I would like to see even more, at least for that's I would say it's my personal view. Usually, especially when you come from academia, are used to collaborate, and I've been 15 years in the academia, so you're used to collaborate all around and with people. So I think that's the way to go. You should really get the fridge from the expert, the cables from the experts, the filters from the experts, the control from the experts, the QPU from the experts, etc., and integrate everything together and make a great quantum computer. That's yeah.
Very cool.
So there hasn't been a lot of public announcements coming out of Israel in terms of what they're doing with quantum computing. We are hearing about other countries that are just being um, just promulgating their information greater. Like, do you find that that's something specifically about Israel that they're not necessarily trying to necessarily show off kind of what they have and what they're doing? It's more of kind of like um an internal project that they're kind of just working on and trying to, see what they can create out of it. What do you think is the is the perception we should take from what Israel does with their information, involving quantum?
Yeah, so I think I missed the first few words that you said, but you said that Israel hasn't been.
Yeah, I haven't really seen them so
No.
much in the news, and and not to say everyone should do what they want to do, and what they think is the most important and appropriate for what they're trying to work on. I find it interesting that constantly Israel is always on the cusp of every new technology that there is, but they keep it a little quiet, a little closer to the vest.
Yeah, so I think like in general, so first of all, the big players dominate also the news. Like you hear about Microsoft, you hear about Google, you hear about IBM, you hear about Intel maybe, I don't know. So that's number one. I think you don't hear about, amazing startups that are rising around the world. And I think that Israel is lagging a bit behind. I think we have great idea. Now we have great ecosystem. That wasn't the case a few years ago. So quantum machines were started in 7 years ago in 2018 and 2019, and then there was like the only quantum company. Later they came like two others, more of software, higher level companies, and only recent 2 years started to grow like this hardware quantum startups. They want to do like full stack quantum computers. So first of all, I think it's lagging a bit behind, but I think that the main thing is that Israel understood it. So we want to be more ahead. But in general, I think that we're rising, and I mean, I hope that we will hear great news in the future. So I think like there are lots of players, small players around the world that you do not hear about. And it doesn't mean that they're not, not will not lead the industry in the future, right?
Well, I
So
also
I
think
don't
too,
think there
like,
is. I don't think there is any intention to hide anything, right? It's
No,
just
I
that
wouldn't mean I didn't mean to imply that. I just thought it was
we're
kind
a
of
bit
interesting.
smaller. Yeah, yeah. No,
I
I
also
completely understand what you mean.
I also think too, like the whole idea, you're the first person to mention that you have like a quantum test bed, right? Where you can hook it up to like one of those cooling systems and try it out. Like I wonder like how many hardware startups are going to come from that, right? And to your point, the fact that you're also focused on educating existing industry professionals, I think is going to, I give it like 3 to 5 years, and you will hear a lot more out of it. I think what you're doing there is very clever because you're planting seeds that will may not bear fruit this year, maybe not next year, but guaranteed they will in the 5 year time frame. Because if you're going to have a quantum workforce, right? The quantum, once there's a practical, and I put practical in air quotes for those listening, right? Because practical, what a practical quantum computer means is slightly different to whoever asks it, right? You ask 5 people, you get 7 different opinions of what a practical quantum computer is. But whenever that happens, whatever that happens, there will be an immediate need for a quantum capable or quantum aware workforce. That's from the people who build data centers, the people who plug stuff into the data centers, the people who write the code on it, the people who get paged out in the middle of the night when something breaks, right? To the marketers, to the CEOs, and all the business line folks. And I think that you're built. I think you're really the first guest to realize like there needs to be kind of a public partner private partnership where you're building out this workforce, because this is going to happen. Now, when it'll happen, I think is the only thing people are debating about. But it's going to happen, and the best way to be prepared for the future is to start learning today. And that's a big rationale for this podcast, right? Like, how do you go from being quantum curious to actually knowing how to talk to customers? How do you explain to? I had a conversation early this morning, oddly enough. Like, how do you explain to a CIO or a CTO or CEO why they should care about quantum computers, right? And kind of like my take was, you have to explain to someone who's not technical, explain like this is coming. It's going to do to conventional computers as you know them today to what computers did to the slide rule and abacus, right? It's going to be like that kind of, I don't want to say quantum leap, but it's going to be that type of jump ahead in processing power. And it's not going to be like, a latest and greatest chip, right? Intel comes out with a new server chip, or, a new i9 chip or i whatever chip, and you plug it into a motherboard, and you plug it into the network, and boom, you suddenly have this magical new thing. It's going to be a completely new ecosystem that has to be built. And, and when you're getting down to brass tacks and kind of practical things, like, I don't know if it's going to happen this year. I don't know if it's going to happen next year. I don't know if it's going to happen in 5 years, right? I don't know. But the best way is to start thinking about that. How are you going to hire quantum people, right? You're going to annoy a lot of people if, say tomorrow, right? This happens, right? Well, we need someone with 5 years experience, developing quantum computers, which is a big annoyance that recruiters do, right? Like, this framework came out a year ago. We need someone with 10 years experience with it. Really? No.
Yeah. Yeah. So, I mean, I think that, the motivation for the Israeli Innovation Authority behind it was kind of, if you build it, they will come, right?
Right,
So
absolutely.
that's the idea. So, I mean, we're open to all of the world. Like, there is no restriction. Like, we're working with the entire world, and Israel as part of this world. But the idea is, that once it's here, it's closer. People are interesting. People are coming. They're looking. They're seeing. They're touching. Then it accelerates everything, And in my opinion, it's working. It's working, even though you might be working a lot with customers. It's still getting traction and hype, and people are hearing about it from their colleagues, and they say, oh, wait, it's right here in Tel Aviv, right? I mean, I can drive 15 minutes and I'm there. Let's go talk to them, see what's happening. And then it's much easier to collaborate and much easier to, execute your great ideas, because, we have this great facility for lease, and you can just go and do stuff that you could not imagine before. So this is really, I think, the motivation behind it, at least in terms of the IIA and obviously for quantum machines.
No, I think it's great. I think it's great. I think the world's going to need a lot more of this to follow the model that you have.
Yeah, I think it's already going, right? So
right.
And obviously in the US it's on a larger scale, but I think we are actually, I mean, I would say, as far as I know, we're the first to build something like that, like a remote accessed quantum data center. And
so were your systems there, are they hybrid?
So the idea here is to build a hybrid system, because so we're seeing that the near future of quantum computing as being hybrid. Like, quantum computers will not stand alone in the next few years. But we believe that, CPUs, GPUs, they can accelerate it. And that's the idea behind the IQCC, is to have a hybrid quantum classical computer. So we work kind of in, I would say, in layers. So the first layer, this is the OPX 1000, the quantum controlled by quantum machines. And this can give you, really fast control in the orders of nanoseconds, okay? Hundreds of nanoseconds, tens of nanoseconds, hundreds of nanoseconds. You can control your qubits. You can do really fast operations on the qubits. But, sometimes you want to do something that you need a larger compute capacity, right? You want to do quantum error correction on 100 qubits. And then you want to go to a classical processor. So what we're now co-developing with NVIDIA, the DGX Quantum, and we just gave the second demo at the APS, the American Physical Society March meeting, is that we have this dedicated communication card, which is being developed by quantum machines. So you can extract the information from the quantum system. It goes out to this communication card with our logic on it, with our IP, and then it can say, okay, what do you want to do next, right? And then if it's a small operation, it goes directly to the OPX 1000, to the control system. But if it's something that you need powerful computation resource, then it will direct you to the NVIDIA Grace Hopper, and then you have CPU, GPU. It can decide, wait, this is a task for CPU, this is a task for GPU, and then it comes back to the control and back to the quantum system, and all of this is done in less than 5 microseconds. So I think we showed 3.7 microseconds. So this is like microsecond time scale, which is shorter than the lifetime. So this is like really still real-time measurements, okay? So this is good for mid-circuit measurements and real-time quantum error correction. And then if you want to go, you need, okay, wait, no, 1 GPU is not enough. I need more. Then we have in a separate room, like a server room, where you have DGX A100 by NVIDIA. That's already 8 GPUs. So you can also take it out there. But this is for like, post-processing. You're done with your measurement. You can take it out. This is milliseconds time scale. And then you have larger a classical compute. And if you want, I would say, infinite classical compute, we're also working with AWS Cloud, so you can take your information to the cloud and run it on as many GPUs as you want. And that will take, a longer time scale. But this is like kind of the layers that we're working on. And this is our, this is where we're focused. And we are really like, Quantum Machines as a company is really, focused on this tightly integration of quantum and classical processing, because we believe that this is the way to go in the future years, in the near future, I mean.
Yeah, I mean, that makes sense. I mean, I think that it's certainly the most practical way forward.
Yeah, I mean, quantum computers, you will not, do your Excel sheet on a quantum computer, or you will not play GTA 6, GTA 7 on your quantum computer. So you will also probably not run things that you run currently on. I don't know if you do, Gen AI and generate, these amazing pictures from The Simpsons. I've been sent,
Yeah, I do.
of my character in Simpsons. So I don't believe you're going to do it on a quantum computer, but we believe that the same as I'm going with my phone. I don't have a GPU here, right?
Right.
And I don't have a GPU on my computer because I can just access the cloud and one thing on AI, and that runs on GPUs. So we believe this will be the same with quantum computers. You will have a quantum computer, and you can just choose what will do the task that you want to do best, or even in the task you want to do, which parts are done best on a CPU, which are done best on a GPU, and which are done best on a QPU. And I think this is really the vision. I don't know to say what will happen in 50, 70 years. I always show this picture when I give this, talks about quantum computing. I always show this picture of, IBM quantum computer, IBM classical computer 80 years ago, right? And it looks exactly similar to what you see here behind me, right? It looks very, very similar. So I say, okay, I don't know if in 80 years this is how the quantum computer will look like, but I know that in 10 years it won't, right? So I think this is the idea. We're not going to hold it in our pocket, but it will do the tasks, and it will, you can direct specific tasks that it will excel in, and things that are not only accelerating classical computing, but actually opens to, complete things that are completely blocked by classical computing. Right. This is basically the hyper-run quantum, because it's a new paradigm. It's not that you can do things faster. It's that you can do things that you could never done with a classical computer, or it would take 1 billion years to do.
Right. Which would be completely impractical, obviously.
Yeah, exactly.
Interesting.
So I think all of these resources should coexist. I don't think, I don't know, Microsoft or Nvidia should be worried about their business, because of quantum computers. Because I think quantum computers will coexist with CPUs and GPUs, and that's at least my vision.
Cool. Any parting thoughts, Candace?
Honestly, I'm just so incredibly fascinated. I really enjoy the whole collaborative effort of what quantum computing can be. That's really what excites me the most, and these data centers and what they can be used for. And you're totally right. Like, we're not going to be solving it for, playing for generative AI. We're not going to be using it, to give us an image or to give us a Simpsons character. It's going to be for the purpose that it's intended for, But no, I love what Nir has explained, and I'm just fascinated by, the next thing that they're going to be able to create there. I mean, it's right behind them. It's very exciting.
And I really like the long view approach you all have taken there, because it's not. You have the test bed. People can come and test their hardware at cryogenic temperatures. You can also, you're also doing the courses for kind of, quote unquote, normal people, right? Not normal, regular people, classical people. There we go.
Classical people. There we go.
So
I like it.
I think it's brilliant. Like, on top of everything else you're doing, and I would encourage others around the world to follow the similar model of, like, start a quantum interest group, or start like a thing where you kind of study groups and things like that. And there's plenty of resources. And I'm also encouraged by the collaborative approach that I'm seeing here. I think it's going to be, accelerate something.
I would love to be able to come back with you, Nir, in a little bit of time, and just to see what has progressed, what has happened, where you are, where you're, the next focus that you have. I think that you have an incredible story to tell, that a lot of people would be really interested in, that is not necessarily being told right now by other companies that are developing different types of technologies. It's really thoughtful and insightful with how you're explaining how this has to evolve and develop, and how really just more people can come in to be involved in it. I think that sounds fantastic.
Absolutely. So keep up the good work, and we definitely want to keep in touch and let us know if you have anything you want to share with us, and our audience in the future. And we encourage those that are listening to go and subscribe to our newsletter. To go to impactquantum.com. In the upper right, there should be a thing that says, join our list, and we'll keep everyone informed of the latest happenings.
I think that sounds great. Thank you, Frank, and thank
Any-
you, Nir. Is there anything that you'd like to tell us as like a parting comment, or a hot take, on quantum computing?
No, I mean, first of all, thanks for having me. It's also good to see that there are, a lot of quantum podcasts. Unfortunately, I don't have. I mean, I don't listen much, but it's really. I mean, when I looked for quantum podcasts, I thought, oh my God, there are so many. Maybe I should start listening. But it's really great to see that. It's also intriguing for the classical people, like you
Yeah, the
called
There we
it.
go.
classical.
Yeah, and I mean, I think that. I think the quantum computing ecosystem is going in the right direction. It grows. I think it still needs, a bit of time to grow, but I think it's really going steady forward. At the IQCC, we're also going to grow a lot this year. So we're going to expand our facility, and I mean everything is expanding. Scaling is the issue,
Right.
and I think this will be the next challenge, right? How do we scale? Oh, this is already the huge challenge, right? Yeah, so we need to scale both in quantum computing and in the quantum audience.
Excellent.
Agreed.
And we'll let our AI, Bailey, finish the show.
And that, dear listeners, wraps up another quantum conundrum cracked wide open here on Impact Quantum. Immense thanks to Nir Alfasi for reminding us that not all heroes wear capes somewhere. Lab coats and hang out next to very, very expensive freezers. If you enjoyed today's episode, do subscribe, leave us a review. And tell a friend, preferably one who thinks Schrodinger's cat is just a weird meme. Until next time, stay curious, stay entangled. And remember, in quantum computing, the future isn't just bright, it's probabilistic.